reading it like left to right, but if you're going to say it in the order which function gets applied first, it would be like GF. Remember, the convention is the function that applies first is written on the right-hand side. Okay, so the composite function, one function after the other. So G first, then F. Right. So the inverse of that is it of this form? Is it like reading from left to right? Would be F inverse G inverse. Is that correct? True or false? Well, what is that? What is the inverse of this composite function? So now G is on the right. Okay, so that's the one you do first. So you do G, then followed by F. That's what this binary operator little circle means, right? In this context, it just is followed by. All right. So we do G first. So let's say we're talking about 3 sets, A, B, and C. So little G here maps from A to B, and then F maps from B to C. Well, if we were to go back, so that is your F, G, right? Now if we want to go back from C to A, this will be your F of G inverse, right? Taking it the other way. Well, to get from C to to get from C to A, how do you do that? Well, you'll do it in 2 steps, right? So you will do the inverse of F, so F inverse, that'll take you to B, and then you do the inverse of G, G inverse, and that'll take you from B to A. So you do F inverse first, and then G inverse. So F inverse first, that's on the right hand side, and then G inverse. Okay? So the answer is that. But that's the opposite of this. So this is false. Okay? So that's just wrong. It's around the wrong way. Assuming that your first one goes on the right hand side. Right? It should be this way. So the answer to 1 is false. Okay. Question 2, I'll just read it out. If F is a bijection, then F is an injection. Right? Did you absorb that? I'll say it once again. If F is a bijection, then F is an injection. True or false? Well, that's one of the easy ones. What is a bijection, by definition? It's a function that's injective and surjective, right? Well, if it's a bijection, that covers injection, so it's obviously true, right? If F is a bijection, then F is an injection. Yes, F is an injection and a surjection, so it's obviously an injection, at least, right? Okay, third one. An injection is a bijection if and only if it's a surjection. So I'll write that. Okay, so you're given that F is an injection, right? You're given that. You start with that. And F is bijective if and only if F is surjective. S is surjective. Right? So if this is true, we have to prove the if and only if. We have to go both ways, right? It's an if type problem. All right. Now, be careful with the wording. An injection is a bijection if and only if it's a surjection. Okay, so we're starting with it being an injection. Right, well, let's do the if case first, as usual. You usually start with the if, right? So B is bijective if F is surjective. So call it statement P, call it statement Q. P if Q. P P is true if Q is true. So start with Q, then P. So what is Q? F is surjective. But that's sort of like extra. We already this is sort of like background. And we know that. We just start that. So given that, if this then that, and if this then that. Right? That's the logic of the situation. Right. Well, if we assume Q, so F is surjective, but we already know F is injective as well. Therefore, F is both injective and surjective. Therefore, it's bijective, right? So that's okay. So P's all right. All right. Now the only if. So that's proving the other way from P to Q. All right. So we know F's injective. That's given. P says F is bijective. And what do we have to prove? That F is surjective. Well, that's trivial, right? Because if P is bijective means injective and surjective. So it must be surjective, right? Hence Q. So that's true. So we've proved it both ways, and hence this statement that I'll read it out again. An injection is a bijection if and only if it is a surjection. So that's true because we proved it. If and only we proved it both ways. So that's okay. All right. Actually, I'll give myself a bit of space. You'll note if this is the first time you see me with this new board, you will see how easily it rubs out. The surface coating or something is distinctly superior to the previous. I'm thinking I got cheated on the first one. Just some fake, some cheap board that passed off as a whiteboard. That's so typical of China. There's just so much fakery going on. So, right. Okay, 4 said, now true or false? So question 4 is, an injection from a finite set to itself. Finite set, so let's say this set, and you're mapping to itself, okay? An injection from a finite set to itself is also a surjection. So A is injective, right? Show that it's surjective. Question mark. So is that true or false? Now it's finite, right? So let's say the size of A is n, right? It has n elements. This set. So it's finite and it's injective. And what does that mean? It means every element. So this is your domain, and this is your codomain, right? Which is itself, in fact. So you're mapping set A into injective, yeah, into itself. So from A to A, and you're asked to show, is it also surjective? All right. Well, think a minute. What does injective mean? Injective means in your codomain, your target set, each element gets mapped to at most once. So in other words, either once or not at all, right? Once or not at all. Cannot be mapped 2 to 1, many to 1. Right? You cannot have any 2 to 1 mappings. You can't, like, say here are 2 elements of A. You cannot have something like this. Yeah? You're not allowed to have 2 to 1 mappings because, by definition, because this mapping, this F, let's say, that's your injective function. that should be f here. Your function is injective, right? Okay, now it's a function, therefore every element in your domain must be mapped, right? If you can't have any unmapped members of your